Lesson 11, Trigonometric Identities and Formula. Hello everyone, I'm Dennis. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out important updates from me. In this lesson, there are many formulas that you need to know. The good news is, most likely, the formulas are given in the exam. However, it will be good if you are familiar with the formula, and it will be best that you know how these formulas are obtained. Hence, in the next few slides, I will show you how we get those formulas. Right, so are you ready? Let's get started. The first type of formulas that you need to know is basic trigonometric identities. Alright, so now let's look at this right angle triangle. And we refer this angle as A. So the opposite side will be A, adjacent side will be B, and this hypotenuse will be C. Alright, so we know that sine A will be A over C, therefore cosecant A will be C over A. Cosine A will be equals B over C. Secant A will be C over B. Tangent A equals A over B. Therefore, cotangent A will be equals B over A. Alright, so now let's move on to Pythagoras theorem. From here, we know that Pythagoras theorem is A squared plus B squared equals C squared. Okay, now what we can do is, for every side here, we divide by C. So therefore, the opposite side will be A over C, the adjacent side will be B over C, and the hypotenuse will be C over C or 1. Right? Now we update Pythagoras theorem, it will be A over C squared plus B over C squared equals C over C squared, which will be sine square A plus cosine square A equals to 1. Alright? So this is the very first formula that you need to know. Okay, now let's move on. Right? Let's say each side we divide B. So the opposite side becomes A over B, the adjacent side becomes B over B, and the hypotenuse will be C over B. Now, the formula becomes A over B squared plus B over B squared equals C over B squared, which is tangent square A plus 1 equals secant square A. So this is the second formula that you need to know. Okay, now let's divide the sides with A. So the opposite side will be A over A, the adjacent side will be B over A, and the hypotenuse side will be C over A. Now we update the Pythagoras theorem again. It will be A over A squared plus B over A squared equals C over A squared. Therefore, the third formula that you need to know is 1 plus cotangent square A equals cosecant square A. This is how we get basic trigonometric identities formulas. The next type of formula that you need to know is compound angle formula. Now let's look at this right angle triangle. We label this angle as A, and there is another right angle triangle stacked at this position, and we name this angle as B. Right? So now, this side will be the side that is shared by these two right angle triangles. Alright, so let's label it as 1 unit. Okay? Now, the opposite side for angle A will be small letter A. Adjacent side will be small letter B. Right? Then the opposite side for the angle B will be C. And the hypotenuse will be D. Okay? Now we draw another right angle triangle here. So this angle will be A. Okay? So, and this side will be E. This side will be F. Okay, now from this diagram, sine A will be equals A, right? Because it is A over 1, so that's why it's A. Cosine A will be equals B. So sine A also will equals F over C if we look at the third triangle. Okay, so F also equals C sine A. Next, cosine A equals E over C. So E will be equals C cosine A. So tangent A equals A over B. Hence, A equals B tangent A. Now, let's look at B. So sine B will be equals C over D. Hence, D equals C over sine B. Cosine B equals 1 over D. Therefore, D will be equals 1 over cosine B. C over sine B equals 1 over cosine B. Alright, so why it is so? Because C over sine B will be this. Alright, it is equal to D, and we know that D also equals 1 over cosine B. Therefore, C over sine B equals 1 over sine B. Okay, from here, we can say that C equals sine B over cosine B, which is tangent B. Okay, now we draw a dotted line here, and we can see that this length will be A plus E. Okay, and this length will be B minus F. Okay, now we refer to this right angle triangle. It will become sine A plus B equals A plus E over D. Okay, so we know that A is, or we can split them into A over D plus E over D. So A is sine A. Right, so from here, we take here A is sine A, D is 1 over cosine B. So where is this part? Which is this one. Okay, and then E will be C cosine A. So where is the E? E is this one. E equals C cosine A, right? And D will be equals C over sine B. So we take this again. Okay, now from here, we can simplify, right? We can say that sine A plus B equals sine A cosine B plus cosine A sine B. Okay, so this is the first formula for compound angle formula. Okay, now we move on to cosine A plus B. So based on this triangle, it will be B minus F over D, right? And then we substitute B, F, and D with, we split them first, B over D minus F over D, right? And then for B will be cosine A over 1 over cosine B. Okay, then C sine A over C sine B. Okay, so why? Because B is this one, right? And C sine A, F is C sine A, so F is C sine A. We take this formula, and then D, right? So D again, we take this D, and okay, so another D will be taking this D. Okay, so then we can simplify this equation, right? It becomes cosine A plus B equals cosine A cosine B minus sine A sine B. Alright, so how to get it? Okay, C and C can cancel. So since it's 1 over cosine B, it becomes cosine A times cosine B. Okay, sine A, right? C can cancel after that. Sine B can move up, becomes sine A times sine B. Right, so this is the second formula, right, for compound angle formula. Cosine A plus B equals cosine A cosine B minus sine A sine B. Okay, how about tangent? Right, now let's look at tangent. Tangent A plus B equals A plus E over B minus F. Okay, so again substitute. A is sine A. Okay, look at here. A is sine A. E is C cosine A. So this is E cosine A. And then B is, so B is cosine A, right? So we look at B is cosine A here. Okay, after that, F is C sine A. Okay, F is C sine A, which is this equation, right? So now we divide cosine A for the numerator and the denominator, and we get sine A over cosine A plus C over 1 minus C sine A over cosine A. Okay, so now, right, so sine A over cosine A is tangent A. So at the bottom also the same, right? Sine A over cosine A is tangent A. And what is C? So C is tangent B. Look at this formula, right? So C is tangent B. Therefore, this C will be tangent B. Okay, this C will be tangent B. Okay, so this is the third formula, right? Tangent A plus B equals tangent A plus tangent B over 1 minus tangent A tangent B. Okay, now let's recap. Sine A plus B equals sine A cosine B plus cosine A sine B. Okay, now if we change the angle B becomes a negative angle, which is negative B. So we update the formula. It will become sine A minus B equals sine A cosine negative B plus cosine A sine negative B. Okay, still remember, when it is a negative angle, cosine negative B is still cosine B. Sine negative B will be negative sine B. So therefore, it will become sine A cosine B minus cosine A sine B. Right? So we combine these two formula together, right? It becomes sine A plus minus B equals sine A cosine B plus minus cosine A sine B. Okay? So this is the formula that you will see in the formula list in the exam. Alright, now let's talk about cosine A plus B. Right, we use a similar concept. Formula is cosine A cosine B minus sine A sine B. So we substitute B becomes a negative B, right, the negative angle. So the formula becomes cosine A minus B equals cosine A cosine negative B minus sine A sine negative B. Alright, so the same concept. Cosine negative is positive, right? So cosine negative B is cosine B. So sine negative B becomes negative sine B. So negative times negative, it becomes positive. So therefore, cosine A minus B is cosine A cosine B plus sine A sine B. Now we combine the two formula together, right? Cosine A plus minus B equals cosine A cosine B minus plus sine A sine B. Okay, so this is the second formula under compound angle formula that you will see in the exam, which is in the formula list will be given, right? So similarly, we move on to tangent A plus B, right? It is equals tangent A plus tangent B over 1 minus tangent A tangent B. So remember, we go to negative angle, right? B becomes negative B. So now tangent A minus B equals tangent A plus tangent negative B over 1 minus tangent A tangent negative B. So negative angle for tangent, right? It will become negative. So therefore, tangent negative B becomes minus tangent B. So over here it is the same. Tangent negative B is negative. So negative times negative becomes positive. Right? So 1 plus tangent AB. Tangent A, tangent B at the bottom. Okay? So we combine the formula, right? It will be tangent A plus minus B equals tangent A plus minus tangent B over 1 minus plus tangent A tangent B. So this is the third formula that you will see under compound angle formula. Now let's talk about double angle formula. Okay, so how we get the double angle formula? We come from this formula addition, right? So sine A plus B equals sine A cosine B plus cosine A sine B. Okay, we do the similar, right? We substitute B equals to A, which becomes sine 2A. Okay, equals sine A cosine A plus cosine A sine A. Alright, so therefore, sine 2A equals 2 sine A cosine A. Okay, so this is the first formula under double angle formula type. Okay, now we move on. Cosine. Cosine A plus B, we know that it is equal cosine A cosine B minus sine A sine B. So we substitute B equals to A. Then the formula becomes cosine 2A equals cosine A cosine A minus sine A sine A, which is cosine square A minus sine square A. And we also, okay, this is the second formula under double angle formula. Okay, we also know from the basic identities cosine square A equals 1 minus sine square A. Okay, now we can substitute 1 minus sine square A inside the formula here. Okay, it becomes cosine 2A equals 1 minus sine square A minus sine square A. And we simplify, it becomes cosine 2A equals 1 minus 2 sine square A. Alright, so this is also the formula for cosine 2A. Okay, another basic identities that we can use here is sine square A. It is equal 1 minus cosine square A. Now we substitute it inside the formula again, right? The original formula for cosine 2A. Now it becomes cosine square A minus bracket 1 minus cosine square A. And we simplify this equation. It becomes cosine 2A equals 2 cosine square A minus 1. Alright, so this formula also is the formula for cosine 2A. Right now, let's move on to tangent A plus B. Okay, we know tangent A plus tangent B over 1 minus tangent A, tangent B. I hope that you know, right, how to get the double angle formula for tangent. Okay, it's the same approach. Okay, where we substitute B equals to A. Right now, it becomes tangent 2A equals tangent A plus tangent A over 1 minus tangent A tangent A. So, simplify, it will become tangent 2A equals 2 tangent A over 1 minus tangent square A. Okay, so this is the double angle formula for tangent function. The next formula that you need to know is half angle formula. Okay, half angle formula comes from the formula of cosine 2A, where cosine 2A there are three formulas, right? Do you still remember? The first one is this: cosine 2A equals to cosine square A minus sine square A. Cosine 2A also equals to 1 minus 2 sine square A, or cosine 2A also equals to 2 cosine square A minus 1. Alright, so how to get this formula we have discussed previously. Okay, then from here, right, we can cut the angles into half, right? From A becomes A over 2. So the first formula, cosine 2A becomes cosine A, right? And then the right hand side, the angle A becomes A over 2. So the whole formula will become cosine A equals cosine square A over 2 minus sine square A over 2. Okay, so similarly for the second formula, cosine A will be equals 1 minus 2 sine square A over 2. And the third formula, cosine A equals 2 cosine square A over 2 minus 1. Alright, so the first formula here, right, can remember, but first formula, we seldom use it. We usually use the second and third formula. Okay, because you can see how we do it, right? So what we want to do is, for the second formula, we make sine A over 2 the subject. So it becomes 2 sine square A over 2 equals 1 minus cosine A, where sine square A over 2 equals 1 minus cosine A over 2. And then, right, we square root both sides. It becomes sine A over 2 equals plus minus square root of 1 minus cosine A over 2. Okay, so this is the formula for a half angle formula for sine function. Now we move on to cosine function, right? We use this the third formula here, right? And we want to make cosine A over 2 the subject. So this formula becomes 2 cosine square A over 2 equals 1 plus cosine A. So cosine square A over 2 equals 1 plus cosine A over 2. And then now we square root both sides. It becomes cosine A over 2 equals plus minus square root of 1 plus cosine A over 2. Okay, so this is the formula for cosine function under half angle formula. Okay, now how about tangent? Okay, so tangent actually is very easy. Tangent function, right? Tangent A over 2 is just simply sine A over 2 over cosine A over 2. Alright, so we can just we find the sine A over 2 first, and then followed by with find cosine A over 2. Then to find tangent A over 2, just take sine A over 2 over cosine A over 2. Okay, now this is the last type of formula that you need to know, the R formula. Okay, how we get this R formula? Now we look at this right angle triangle. So let's say this angle is alpha. Okay, the opposite side will be B, the adjacent side will be A, hypotenuse side will be capital R. Okay, so now we know that sine alpha is B over R. So B will be equals R sine alpha. Cosine alpha will be equals A over R. So A will be equals R cosine alpha. And R is equals square root of A squared plus B squared based on Pythagoras theorem. Okay, therefore, and then alpha will be inverse of tangent B over A. Okay, now let's look at this A sine theta plus minus B cosine theta. Okay, we can substitute, right, the formula here. Can you see, right? A equals R cosine alpha. So therefore, A sine theta will be R cosine alpha sine theta. And then B, right? B will be R sine alpha. So it be R sine alpha cosine theta. Okay, and then we can factorize the R. It will be R bracket sine theta cosine alpha plus minus cosine theta sine alpha. Okay, and then, right, we can say that A sine theta plus minus B cosine theta equals R sine theta plus minus alpha. Okay, remember the formula, right? Sine A plus B equals sine A cosine B plus cosine B sine A. Okay, so this is the first formula for R formula, right? A sine theta plus minus B cosine theta equals R sine theta plus minus alpha. Okay, now how about cosine? Right, so now the cosine theta first followed by sine theta. Okay, just now the first formula, right? We have sine first followed by cosine. Okay, so we will do the similar approach. So A is R cosine alpha. So then become R cosine alpha cosine theta. B is R sine alpha. So become R sine alpha sine theta. Okay, we do the same approach, factorize the R. Then we have this R bracket cosine theta cosine alpha plus minus cosine theta cosine alpha. Okay, so this is actually cosine theta minus plus alpha. Alright, so remember the compound formula. Okay, so therefore, right, A cosine theta plus minus B sine theta equals R cosine bracket theta minus plus alpha. Okay, so remember this formula. R is equals square root of A squared plus B squared, and alpha is equals tangent inverse B over A. Okay, we have discussed how we get all those formula. Now let's recap and summarize the formulas. Okay, so again, as I said just now, you don't have to know how to prove those formula. So what you need to do is, right, you need to know those formula and how to use it. Okay, yeah, the first type of the formula is called the basic identities. So the formula are sine square A plus cosine square A equals to 1. Tangent square A plus 1 equals secant square A. And 1 plus cotangent square A equals cosecant square A. Right? So how to use this formula, right, is you see that if you encounter square trigo functions like sine square A, cosine square A, or tangent square A, or even secant square A and cotangent cosecant square, right? So to use basic identities, usually when you encounter square trigo square function, or it involves 1. Okay, you can see that these three formulas, there is 1. Okay, you can sometimes you can say it is equal sine square A plus cosine square A. Okay, so I think this first formula we use it quite often. So this is basic identities. Okay, second type of formula is compound angle formula. So we have this sine A plus minus B equals sine A cosine B plus minus cosine A sine B. Cosine A plus minus B equals cosine A cosine B minus plus sine A sine B. Tangent A plus minus B equals tangent A plus minus tangent B over 1 minus plus tangent A tangent B. Okay, so when do you know you need to use this formula? So usually, right, is you see that the trigo function sine, cosine, tangent, the angles, right, there are two angles plus minus together. Okay, then you use this formula, compound angle formula. Okay, the next one, double angle formula. So we have this sine 2a equals 2 sine a cosine a. Cosine 2a equals cosine a, cosine square a minus sine square a, or 1 minus 2 sine square a, or 2 cosine square a minus 1. Okay, the tangent function will be tangent 2a equals 2 tangent a over 1 minus tangent square a. Okay, so when do you know you need to use this formula, double angle formula? So you look at the name, you should know the idea, right? So when you see that it involves a double of an angle 2a, right? So sometimes like you want to double up the angle, right? Or you want to lower down the angle, right? So half the angle, it's like 2a becomes a. You can see that 2a becomes a. Okay, so that's where you use the double angle formula, which we have this half angle formula. Okay, so this half angle formula actually derived from double angle formula, where sine a over 2 equals plus minus square root of 1 minus cosine a over 2. Cosine a over 2 equals plus minus square root of 1 plus cosine a over 2. Tangent a over 2 is sine a over 2 over cosine a over 2. So we find the sine and cosine a over 2 first, then you can find tangent a over 2. Alright, so when to use the half angle, you can obviously from the formula, right? When you want to half your angle a over 2, then you will need to use this half angle formula. And one thing you need to take note, right, is that half angle formula is not given in the formula list. So I don't really recommend you to memorize it. So what you can do is you can just derive, right, this formula from here and this formula. Okay, what you need to do is just make sine the subject. Okay, sine a becomes a over 2, 2a becomes a. Okay, so then you make sine the subject, you get this formula, sine a over 2. You get this formula. Okay, cosine a over 2, right? You just use the second this formula, right? 2a becomes a becomes a over 2. So then you make cosine a over 2 the subject, you get this formula. Alright, so this is half angle formula. Then the last formula you need to know is R-formula. Okay. So one thing you need to take note is that for R-formula, it is not in the formula list. Okay, so the first one will be R sine theta plus minus B cosine theta equals R sine theta plus minus alpha. Okay, and A cosine theta plus B sine theta equals R cosine theta minus plus alpha. Okay, so from here, right, the A and B are constants. Okay, you can see that A and B are constant. And then this alpha, right, you can get from this formula. Okay, and then R, capital R, right, you get from the Pythagoras theorem, square root of A square plus B square, which you apply the Pythagoras theorem to get the R. Okay, so now how do you know you need to use R formula? You look at the formula here, right? Firstly, it involves sine and cosine. Okay, either sine first then cosine or cosine first then sine. Okay, you need to pay attention here. You get different formula. Okay, don't mix them up. Okay, so how to remember, right? If start with sine, then your R formula will be sine. If start with cosine, then the R formula will be cosine. Okay, and then both trigo, the angle is the same. Okay, and then you have constants for sine and cosine, right? Then you can convert to R formula. And the next question is why we need to convert to R formula. It will happen when right? This when you encounter a sine theta plus minus b cosine theta not equals to 0, or when a cosine theta plus minus b sine theta is not equal to 0, so you have to convert them into R formula so that you can solve the equation. Okay, I think in the next section, right, we'll see examples on how to apply R formula. After discussing all the formulas that you need to know, now let's talk about how we can apply those formulas to solve trigonometric questions. The first type of question is finding trigonometric ratios. Here is one example. Given that tangent theta equals 4/3 and that the range of theta is from 90 degrees to 360 degrees, find the value of each of the following without using calculator. 1. Cosine negative theta. 2. Cosine 90 degrees minus theta. 3. Sine 180 degrees plus theta. 4. Sine 2 theta. Here is the solution. Before we want to find the values of these trigo, we need to draw the diagram. Okay, from the given information, tangent theta equals 4/3 and the range of theta is from 90 degrees to 360 degrees. We know that tangent is positive, hence the angle is at third quadrant. Okay, now we can start to draw the diagram. The angle is in the third quadrant, so it turns in this angle theta, and we can draw a right angle triangle. So this is the opposite side with the value of -4. This is the adjacent side with the value of -3. And this is the hypotenuse 5, because based on Pythagoras theorem, these are the numbers 3, 4, and 5 which obey Pythagoras theorem. Okay, now we can find the values of the trigos here. Cosine negative theta is cosine theta, because we know that this is a negative angle. So cosine negative theta will be equals cosine theta. From the triangle in the diagram, it is -3/5. Number 2, cosine 90 degrees minus theta. So cosine 90 degrees minus theta equals sine theta. And from the diagram, it is -4/5. 3. Sine 180 degrees plus theta, it is equal negative sine theta. And from the diagram, it is 4/5. Number 4. Sine 2 theta. Okay, from here, this is a double of the angle. We can apply double angle formula, which equals 2 sine theta cosine theta. Okay, so we already know sine theta is -4/5, cosine theta is -3/5. So just take these values into the equation and we will get the answer 24/25. Okay, now it's your turn to try these similar questions yourself. Given that sine A equals 4/5 and cosine B equals -12/13, where A and B are in the same quadrant, without using calculator, find the value of each of the following. A. Cosine A. B. Cosine 2A. C. Cosine half A. D. Sine B. E. Sine 2B. F. Sine half B. G. Cosine A plus B. H. Tangent A minus B. Okay, you can pause the video and try to solve this question yourself. Alright, here is the solution. So from the given information, we find that sine is positive and cosine is negative. Therefore, both are in the second quadrant. Now we can start to draw the quadrants. So for A, it turns this angle and it forms this triangle. The opposite side is 4 and the adjacent side is -3. hypotenuse is 5. For angle B, this is the angle B. It forms a right angle triangle. This length, the opposite length is 5. The adjacent length is -12. And the hypotenuse is 13. Okay, so how to get these values, right? Remember, we always apply Pythagoras theorem. Okay, now we can start to answer the question. A cosine A, so it is -3/5. B cosine 2A, so this is double angle, hence we can apply double angle formula, which is we can choose cosine square A minus sine square A. Right, so from the diagram we can get cosine A is -3/5, sine A is 4/5. So cosine 2A will be -3/5 square minus 4/5 square. And we get the answer is -7/25. C. We know that A is in the range of 90 degrees to 180 degrees. We want to find cosine half A. So half A will be in the range of 45 degrees to 90 degrees. And from here, the angle is at the first quadrant. So we can apply the half angle formula. Cosine half A equals square root of 1 plus -3/5/2. And you notice that we don't include the negative sign because, as we have mentioned just now, angle is at the first quadrant, cosine is positive. Okay, and we get the answer is 1/5. Or we can simplify, it becomes 5/5. Okay, now let's move on to D. So D is sine B. From the diagram, it is 5/13. For E, sine 2B, again this is double angle. We can apply the double angle formula. It equals 2 sine B cosine B. And from the diagram, sine B is 5/13, cosine B is -12/13. So the answer for sine 2B is -120/169. F. So the range of B is from 90 degrees to 180 degrees. So half B will be 45 degrees to 90 degrees. Okay, so we know that the angle is in the first quadrant. And now I believe you know what to do, right? So this is half angle. We can use half angle formula. Sine half B equals square root of 1 minus cosine B/2. Okay, and then from here, cosine B is -12/13. Just substitute the value inside. We get 5/26. Rationalize, the answer becomes 5/26/26. Now let's move on to G, cosine A plus B. So the formula is cosine A, cosine B minus sine A and sine B. So from the diagram, we know cosine A is -3/5, cosine B is -12/13, sine A is 4/5, sine B is 5/13. So we put them together into this equation and we get the answer is 16/65. H. Tangent A minus tangent B. So firstly, we need to find tangent A equals to -4/3. Tangent B equals to -5/12. We get these values from the diagram. Okay, so from here, tangent A minus B, the formula is equal tangent A minus tangent B over 1 plus tangent A, tangent B. Then we put in the value, right? Tangent A is -4/3, tangent B is -5/12. So inside into the equation is -4/3 plus -5/12 over 1 plus -4/3 times -5/12. Okay, we press the calculator and we get the answer is -9/8. Now we try to apply the formula to solve trigonometric equations using basic trigonometric identities. Here is the example. Find all the angles between 0 and 2 pi inclusive which satisfy the equation 3 tangent square x plus 5 equals 7 secant x. Here is the solution. When an equation contains square of trigo, we can consider to use basic identities formula. Okay, from here, 3 tangent square x plus 5 equals 7 secant x. From the formula, tangent square a plus 1 equals secant square a. Tangent square a will be equals secant square a minus 1. Therefore, we can substitute this formula into the equation, which becomes 3 bracket secant square a minus 1 plus 5 equals 7 secant x. Then we expand, we get 3 secant square a minus 3 plus 5 equals 7 secant x. Then rearrange the equation, becomes 3 secant square a minus 7 secant x plus 2 equals to 0. Okay, do you see this is a quadratic equation? We can actually factorize it, becomes 3 secant a minus 1 secant a minus 2 equal to 0. Hence 3 secant a minus 1 equals to 0, or secant a equals to 2. Secant a minus 2 equals to 0. So secant a equals to 1 over 3, or secant a equals to 2. Okay, then we know secant a is 1 over cosine a. Therefore, cosine a equals to 3, cosine a equals to half. However, we know that cosine a cannot be greater than 1. Therefore, the first equation, there is no solution. Now we move on to the second equation, cosine a equals to half. The basic angle is pi over 3. Cosine is positive, therefore it is in the first and the fourth quadrant. Therefore, a will be pi over 3, 2 pi minus pi over 3. And we get the answer for a is pi over 3 and 5 pi over 3. Alright, so here you can try similar example yourself. Solve the following equations for the range of x from 0 to 360 degrees. A, 4 cosine square x plus 2 sine square x equals to 3. B, 5 secant x plus tangent square x equals negative 5. You can pause the video and try to solve it yourself. Okay, here is a solution. For A, we can use this formula, cosine square x plus sine square x equals to 1. So, cosine square x equals to 1 minus sine square x. We can substitute inside the equation for cosine square x plus 2 sine square x equal to 3. So, cosine square x becomes 1 minus sine square x. Then we expand the bracket. It will become 4 minus 4 sine square x plus 2 sine square x equals to 3. And we get 2 sine square x equals to 1. Sine x will be equals plus minus square root of 0.5. Basic angle is 45 degrees. So since it is including plus and minus, that means the angle involves all the 4 quadrants. Hence, x will be 45 degrees, 180 degrees minus 45 degrees, 180 degrees plus 45 degrees, and 360 degrees minus 45 degrees. And the answer is 45 degrees, 135 degrees, 235 degrees, and 315 degrees. Okay, so alternatively, you may also use sine square x equals 1 minus cosine square x. Alright, so that means when you substitute inside the equation, sine square x is eliminated. We only need to solve cosine square x. B, from the tangent square a plus 1 equals secant square a, we can make tangent square x a subject. We get secant square a minus 1. Okay, so given the equation 5 secant x plus tangent square x equals to negative 5, substitute tangent square x with secant square x minus 1. Okay, then we expand, we get secant square x plus 5 secant x plus 4 equal to 0. Factorize, it becomes secant x plus 1. Secant x plus 4 equals to 0. So secant x equals negative 1, or secant x equals negative 4. Therefore, cosine A equals to -1, or so x will be equals 180 degrees. Or cosine x equals -1/4. Basic angle is 75.5 degrees. So it is negative, therefore it is in the second and the third quadrant. Hence, x equals 180 degrees minus 75.5 degrees and 180 degrees plus 75.5 degrees. The answer is x equals 104.5 degrees and 255.5 degrees. We put everything together. The answer for x equals 104.5 degrees, 180 degrees, and 255.5 degrees. Now, let's try to apply compound angle formula to solve trigonometric equation. Here is the example. Find all the angles between 0 and 360 degrees inclusive which satisfy the equation 3 cosine x minus 60 degrees equals sine x plus 150 degrees. Here is the solution. From compound angle formula, sine A plus minus B equals sine AB cosine B plus minus cosine A sine B, and cosine A plus minus B equals cosine A cosine B minus plus sine A sine B. We get from the given equation 3 cosine x minus 60 degrees equals sine x plus 150 degrees. Now we apply the compound angle formula. It becomes 3 bracket cosine x cosine 60 degrees plus sine x sine 60 degrees equals sine x cosine 150 degrees plus cosine x sine 150 degrees. Okay, so now cosine 60 degrees is half, sine 60 degrees is sub3/2, cosine 150 degrees is negative sub3/2, and sine 150 degrees is half. Therefore, the equation becomes 3 bracket half cosine x plus sub3/2 sine x equals negative sub3/2 sine x plus half cosine x. Then we expand, which get us 3/2 cosine x plus 3 sub3/2 sine x equals negative sub3/2 sine x plus half cosine x. And then we bring the sine x to left hand side and cosine x to right hand side. We get 2 sub3 sine x equals negative cosine x. Next, we bring all the trigo function at left hand side and the constants at right hand side. We get sine x over cosine x equals negative 1/2 sub3, which means tangent x equals negative sub3/6. Right? Then from here, we can solve the equation. The base angle is 16.1 degrees. Tangent is negative, therefore it is in the second and the fourth quadrant. So the x will be equals 180 degrees minus 16.1 degrees and 360 degrees minus 16.1 degrees. And we get the answer is 163.9 degrees and 343.9 degrees. Okay, so the answer is 1 decimal place. Now, here is your turn to solve this similar example yourself. Find all the angles between 0 and 360 degrees inclusive which satisfy the following equations. A. 2 tangent x minus 45 degrees plus 3 tangent x equals 0. B. 4 cosine 2x sine x equals 4 sine 2x cosine x equal plus 3. You can pause the video and try to solve it yourself. Okay, here is a solution for A. We can use substitution formula. Tangent A plus minus B equals tangent A plus minus tangent B over 1 minus plus tangent A tangent B. So substitute into the given equation 2 tangent x minus 45 degrees plus 3 tangent x equals 0. So it will become 2 bracket tangent x minus tangent 45 degrees over 1 plus tangent x tangent 45 degrees plus 3 tangent x equals 0. Okay, we know that tangent 45 degrees is 1. So inside the bracket, it will become tangent x minus 1 over 1 plus tangent x. Then we expand. It will become 2 tangent x minus 2 over 1 plus tangent x plus 3 tangent x equal to 0. So now everything times with 1 plus tangent x, we get 2 tangent x minus 2 plus 3 tangent x bracket 1 plus tangent x equals 0. Next, expand the bracket. We get 2 tangent x minus 2 plus 3 tangent x plus 3 tangent square x equal to 0. Okay, then we simplify. It becomes 3 tangent square x plus 5 tangent x minus 2 equal to 0. And this is a quadratic equation. We can factorize, which becomes 0 equals tangent x plus 2, 3 tangent x minus 1. It means tangent x equals to negative 2 or tangent x equals to 1 over 3. Okay, and now we don't reject tangent x equals negative 2 because tangent can be more than 1. Therefore, the best angle is 63.4 degrees. And it is in the second and the fourth quadrant because tangent is negative. Hence, x is 180 degrees minus 63.4 degrees, 360 degrees minus 63.4 degrees. The answer is 116.6 degrees and 296.6 degrees. Then we move on to the second equation. Tangent x equals to 1/3. The best angle alpha is 18.4 degrees. And now tangent is positive. Hence, it is in the first and the third quadrant. So x will equals 18.4 degrees and 180 degrees plus 18.4 degrees. And the answer is 18.4 degrees and 198.4 degrees. Okay, now we combine all the answers together. The x equals 18.4 degrees, 116.6 degrees, 198.4 degrees, and 296.6 degrees. Okay, now let's look at the solution for B. So given the equation 4 cosine 2x sine x equals 4 sine 2x cosine x plus 3. Okay, we can bring the term with trigo to left hand side, constant at right hand side, and the equation becomes 4 sine 2x cosine x minus 4 cosine 2x sine x equals negative 3. And we can divide by 4 for both sides. We get sine 2x cosine x minus cosine 2x sine x equals negative 3 over 4. And from here, we can apply the formula sine a plus minus b equals sine a cosine b plus minus cosine a sine b. Hence, the equation becomes sine 2x minus x equals negative 3 over 4, which is sine 3x, sine x equals negative 3 over 4. And we can start to solve the equation. So the best angle is 48.6 degrees. Sine is negative. Therefore, it is in the third and the fourth quadrant. So the x will be equals 180 degrees plus 48.6 degrees. 360 degrees minus 48.6 degrees. And the answer is 228.6 degrees and 311.4 degrees. Now, let's see another types of question which is very popular and almost come up in the O Level exam almost every year. The question is proving trigonometric identities. Okay, here is the example. Prove each of the following identities. A, 1 over 1 plus cosine theta plus 1 over 1 minus cosine theta equals 2 cosecant square theta. B, secant to the power 4 theta minus secant square theta equals tangent square theta plus tangent to the power 4 theta. Okay, now look at this question, right? It seems like it is an equation, but it is not. We need to prove from left equals to the right. Okay, so now you should start from one side. Okay, now let's look at A first. We start from left hand side. Actually, you can start from right hand side if you like. Right, let's say I want to start for A from the left hand side, which equals 1 over 1 plus cosine theta plus 1 over 1 minus cosine theta. So what I'm going to do is I will combine these two fractions together into one fraction, okay, and it will become 1 minus cosine theta plus 1 plus cosine theta over 1 plus cosine theta times 1 minus cosine theta. Okay, then we simplify, it will become 2 over 1 minus cosine square theta. And we know that from the formula, sine square A plus cosine square A equals to 1. 1 minus cosine theta will be equals sine square theta. Therefore, it becomes 2 over sine square theta, which is equal to cosecant square theta. So it is equal to the right hand side. Hence, I have proven these two identity. B. I start from the left hand side, which equals secant to the power 4 theta minus secant square theta. Okay, I can factorize secant square theta. It becomes secant square theta bracket secant square theta minus 1. And from the formula, tangent square A plus 1 equals secant square A. So secant square theta becomes tangent square theta plus 1, then times tangent square theta, and it becomes tangent to the power 4 theta plus tangent square theta. It is equal to right hand side, and I have proven that the identities for B is true. Okay, now it's your turn to try this similar example yourself. Prove each of the following identities. A. Cosine x minus sine x square equals 1 minus 2 sine x cosine x. B. Cosecant x minus sine x equals cosine x cotangent x. C. 1 plus cosine x over sine x plus sine x over 1 plus cosine x equals 2 cosecant x. D. Secant x plus cosecant x over tangent x plus cotangent x equals sine x plus cosine x. Okay, you can pause the video and try to solve it yourself. Okay, here is the solution. For A, we start from the left hand side, which is cosine x minus sine x square. We can expand the bracket, which we get cosine square x minus 2 cosine x sine x plus sine square x. And we know that cosine square x plus sine square x equals to 1. Therefore, it will become 1 minus 2 cosine x sine x. So it is equal to right hand side, and it is proven. For B, we start from the left hand side, which equals cosecant x minus sine x. Okay, we know that cosecant x equals 1 over sine x. Therefore, it is 1 over sine x minus sine x. And combine these two terms together, it becomes 1 minus sine square x over sine x. And we know that 1 minus sine square x is cosine square x. Then it is cosine square x over sine x. Right? We break it into 2. So it equals cosine x times cosine x over sine x, which becomes cosine x cotangent x. So it is equal to right hand side, and it is proven. Here is the solution for C. From the left hand side, 1 plus cosine x over sine x plus sine x over 1 plus cosine x. So we combine these two fractions together, which becomes 1 plus cosine x square plus sine square x over sine x times 1 plus cosine x. We open the bracket, it becomes 1 plus 2 cosine x plus cosine square x plus sine square x over sine x times 1 plus cosine x. And we know that cosine square x plus sine square x equals 1. So it becomes 1 plus 2 cosine x plus 1 over sine x times 1 plus cosine x. So simplifying, it is 2 plus 2 cosine x over sine x times 1 plus cosine x. Factorize the 2, it becomes 2 times 1 plus cosine x over sine x times 1 plus cosine x. And we notice that we can cancel 1 plus cosine x right from the top and the bottom. It becomes 2 over sine x, which equals 2 cosecant x equals right hand side, proven. Okay, here is the solution for D. We start from the left hand side, secant x plus cosecant x over tangent x plus cotangent x. We can change all the trigo into the basic trigos, where secant x is 1 over cosine x, cosecant x is 1 over sine x, tangent x is sine x over cosine x, cotangent x is cosine x over sine x. Then we combine them together, right? Two fractions into one. So sine x plus cosine x over cosine x sine x over sine square x plus cosine square x over cosine x sine x. Okay, so now I break this the numerator and the denominator into 2, right? And it becomes times. From division becomes multiplication. So sine x plus cosine x over cosine x sine x times cosine x sine x over sine square x plus cosine square x. And we can see that we can cancel cosine x sine x, and sine square x plus cosine x is 1. Therefore, it becomes sine x plus cosine x, which equals right hand side and proven. Okay, now let's apply compound angle formula to evaluate trigonometric ratios. Here is the example. A and B are acute angles such that sine A plus B equals 3 over 10 and sine AB cosine B equals 2 over 5. Without the use of a calculator, find the value of A, cosine A cosine B, B, sine A minus B, C, tangent A over tangent B. Here is the solution. For A, okay, we know that sine A plus B equals sine A cosine B plus cosine A sine B. Okay, so we given sine A plus B is 3 over 10, sine A cosine B is 2 over 5. So apply these two values into the equation, and we get cosine A sine B equals negative 1 over 10. For B, sine A minus B, apply the formula, it becomes sine A cosine B minus cosine A sine B. Now we just plug in the values inside. Sine A cosine B, we know that the value is 2 over 5. Cosine A sine B, from solution A, we know that the value is negative 1 over 10. So the answer is 1 over 2. For C, tangent A over tangent B, we can write in this way. Tangent A times 1 over tangent B. Okay, now it becomes sine A over cosine A times cosine B over sine B. And we can combine them together, becomes sine A cosine B over cosine A sine B. And we know that sine A cosine B is 2 over 5. Cosine A sine B is negative 1 over 10. Okay, and we calculate it, we get negative 4. Okay, you can try this example. A and B are acute angles such that cosine A minus B equals 7 over 12 and cosine A cosine B equals 1 over 4. Without the use of calculator, find the value of A, sine A sine B, B, cosine A plus B, C, tangent A, tangent B. You can pause the video and try to solve it yourself. Alright, here is the solution. For A, we know that cosine A minus B equals cosine A cosine B plus sine A sine B. Just plug in the value, right? Cosine A minus B is 7 over 12, cosine A cosine B is 1 over 4. So we get sine A sine B equals 1 over 3. For B, Cosine A plus B equals cosine A cosine B minus sine A sine B. Okay, we know cosine A cosine B is 1 over 4, sine A sine B is is 1 over 3. So it will become 1 over 4 minus 1 over 3. The answer is negative 1 over 12. For C, tangent A, tangent B, so we can write in this way, sine A over cosine A times sine B over cosine B. Combine them together, sine A over sine B over cosine A cosine B. And we know sine A sine B is 1/3, and cosine A cosine B is 1 over 4. The answer for tangent A and tangent B is equal 4 over 3. Okay, now let's learn how to find the exact values of trigonometric ratios of specific angles. Here is the example. Without the use of calculator, find the value of A cosine 75 degrees, B sine square 22.5 degrees, and C cosine to the power 4 15 degrees minus sine to the power 4 15 degrees. Here's the solution. For cosine 75 degrees, we can rewrite it to be cosine bracket 45 degrees plus 30 degrees. And we apply the formula, it becomes cosine 45 degrees, cosine 30 degrees minus sine 45 degrees, sine 30 degrees. Okay, why do we choose the angle of 45 degrees and 30 degrees? Because they are special angles. We know that cosine 45 degrees is sec 2 over 2, cosine 30 degrees is sec 3 over 2, sine 45 degrees is sec 2 over 2, and sine 30 degrees is half. Alright, then we solve this equation and we get the answer sec 6 over minus sec 2 over 4. Okay, for B, sine square 22.5 degrees. Okay, usually when you see angles with 0.5 degrees, right, you can consider to use the half angle formula. So it is sine square 45 degrees over 2. Okay, based on a half angle formula, sine square A over 2 is 1 minus cosine A over 2. Okay, apply it inside the equation. Sine square 22.5 degrees equals 1 minus cosine 45 degrees over 2. Okay, and apply the value. Cosine 45 degrees is 1 minus cosine 45 degrees is 2 over 2. Okay, the value is 2 minus 2 over 4. Okay, here is a solution for C. Cosine to the power 4 15 degrees minus sine to the power 4 15 degrees. We can factorize it. It becomes cosine square 15 degrees plus sine square 15 degrees times cosine square 15 degrees minus sine square 15 degrees. So cosine square 15 degrees and sine square 15 degrees will give us 1. Cosine square 15 degrees minus sine square 15 degrees. This is a double angle formula, right, which gives us cosine 30 degrees. Hence, the answer is sec 3 over 2. Okay, now it's your turn to try this similar example yourself. Without using a calculator, show that A tangent 15 degrees equals 2 minus sec 3. B tangent 15 degrees equals 1 over 4 secant square 15 degrees. C cosine 105 degrees equals sec 2 bracket 1 minus sec 3 over 4. You can pause the video and try to solve it yourself. Okay, here is the solution. Okay, for A tangent 15 degrees, right, we can write it to be equals tangent 30 degrees over 2. So from here, we can apply the half angle formula, and this is a tangent 15 degrees. Therefore, we need to find sine and cosine 15 degrees first. So we know that sine A over 2 equals plus minus square root of 1 minus cosine A over 2. So therefore, sine 15 degrees equals sec 1 minus cosine 30 degrees over 2. Okay, cosine 30 degrees is sec 3 over 2. So this equation becomes bracket 2 minus sec 3 over 4 to the power half. Okay, another one, cosine A over 2 equals plus minus sec 1 plus cosine A over 2. And we need to take the positive because cosine, the 15 degrees is in the first quadrant. Okay, it is equals sec 1 plus cosine 30 degrees over 2. Cosine 30 is sec 3 over 2, right? The equation becomes 2 plus sec 3 over 4. Then to the power half. Now we can find tangent 15 degrees. So tangent 15 degrees will be equals sine 15 degrees over cosine 15 degrees. Okay, from the values that we have obtained, sine 15 degrees is 2 minus 3 over 4 to the power of half divided by cosine 15, which is 2 plus 3 over 4 to the power of half. Okay, the division sign change to multiplication sign. It becomes times 4 over 2 plus 3 to the power of half. Combine them together, the 4 and 4 can cancel to each other, and we get 2 minus 3 over 2 plus 3 to the power of half. Okay, and then we rationalize, which becomes 2 minus 3 times 2 minus 3 over 2 plus 3 times 2 minus 3 to the power of half. We get 2 minus 3 square over 4 minus 3 to the power of half, and eventually is 2 minus 3 square to the power of half, and final answer 2 minus 3. So shown. For B, we'll start from 1 over 4 secant square 15 degrees. So it is equals 1 over 4 times 1 plus tangent square 15 degrees. Okay, we know that tangent 15 degrees is 2 minus 3. Okay, so it becomes 1 over 4 bracket 1 plus 2 minus 3 square. Now we expand the bracket, it becomes 1 over 4 bracket 1 plus 4 minus 4 3 plus 3. Simplify, it becomes 1 over 4 bracket 8 minus 4 3, and we get 2 minus 3, which equals tangent 15 degrees, hence shown. Okay, for C, cosine 105 degrees, we can rewrite it to become cosine 60 degrees plus 45 degrees. Then we apply the formula, which becomes cosine 60 degrees cosine 45 degrees minus sine 60 degrees sine 45 degrees. So for cosine 60 degrees, it is half. Cosine 45 degrees is 2 over 2. Sine 60 degrees is 3 over 2. Sine 45 degrees is 2 over 2. So we put everything together, and we get the answer 2 over 2 minus 2 times 3 over 4. Factorize 2, it becomes 2 bracket 1 minus 3 over 4. So it's the same answer which need us to prove, hence shown. Now we can see how we can apply our formula. Here is an example. By expressing 4 cosine x minus 3 sine x in the form r cosine x plus alpha, where r is greater than 0, and the range of alpha is between 0 to pi over 2. 1. Find the maximum value of 4 cosine x minus 3 sine x plus 5. 2. Solve the equation 4 cosine x minus 3 sine x equals 2.5 for values of x between 0 and 2 pi inclusive. Here's the solution. We can apply the R formula. Now the 4 cosine x minus 3 sine x equals r cosine bracket x plus alpha, where a equals 4 and b equals 3. So we can get the r value, which is square root of 4 square plus 3 square equals 5. Next, we find the value of alpha, which is inverse of tangent b over a, or inverse of tangent 3 over 4, and we get the value is 0.6435 in radian. Hence, we can rewrite the equation becomes 4 cosine x minus 3 sine x equals 5 cosine bracket x plus 0.6435. Now, we can answer the question. So from the R formula that we have converted, right, the maximum value of 4 cosine x minus 3 sine x equals to 5. Okay, hence we can say that the maximum value of 4 cosine x minus 3 sine x plus 5 equals 5 plus 5. Okay, remember this 4 cosine x minus 3 sine x, maximum value is 5. So it's 5 plus 5, then answer is 10. Okay, now we can solve the equation. 4 cosine x minus 3 sine x equals 2.5, and we convert 4 cosine x minus 3 sine x into 5 cosine bracket x plus 0.6435 equals 2.5. Now make cosine x plus 0.6435 the subject, which equals to 0.5. So the basic angle is pi over 3. Okay, cosine is positive, it is in the first and the fourth quadrants. Hence, x plus 0.6435 equals pi over 3 and 2 pi minus pi over 3. The x value will be equals 0.404 and 4.59. Answer in 3 significant figures. Okay, now you can try this example yourself by expressing sub 5 cosine x plus 2 sine x in the form of r cosine x minus alpha, where r greater than 0 and the range of alpha is from 0 to pi over 2. Find the minimum value of sub 5 cosine x plus 2 sine x plus 6 and solve the equation sub 5 cosine x plus 2 sine x equals to 1 for values of x between 0 and 6 inclusive. You can pause the video and try to solve it yourself. Here is the solution. So we convert the expression into R-formula first, right? The sub 5 cosine x plus 2 sine x equals r cosine x minus alpha, where a is sub 5 and b is 2. So the r value will be square root of sub 5 square plus 2 square, and we get 3. The alpha is inverse of tangent b over a, which is inverse of tangent 2 over sub 5, and the value is 0.7297 radian. Hence, sub 5 cosine x plus 2 sine x equals 3 cosine bracket x minus 0.7297. Okay, now we can answer the question, right? Minimum value. So from the value or to the conversion we got, right, the sub 5 cosine x plus 2 sine x, the minimum value will be negative 3. Okay, look at here. This is the amplitude. So the minimum value will be negative 3. So now we can get the minimum value of sub 5 cosine x plus 2 sine x plus 6. So we know that this value is minimum, which is negative 3, then plus 6, and the value is 3. And now we can solve the equation sub 5 cosine x plus 2 sine x equals 1, which is 3 cosine bracket x minus 0.7297 equals 1. Make cosine the subject, and we find that cosine is positive. Now we can solve it. The basic angle is 1.2310 radian. So cosine is positive. It is in the first and the fourth quadrants. So the x minus 0.7297 equals 1.2310, and 2 pi minus 1.2310. So now the x is 1.96 and 5.78. Answer in 3 significant figures. Now let's look at application of R-formula. Here is the example. Given that this diagram, okay, so the diagram shows a field ABCD in the shape of a quadrilateral with AD is perpendicular to CD. AD is 60 meters, DC is 40 meters, BD is 50 meters, and angle ADB is theta, where theta is measured in degrees. The area of ABCD is denoted by S meters square. So here's the question. The first one, show that S equals 1500 sine theta plus 1000 cosine theta. 2. Express S in the form of R sine theta plus alpha, where R greater than 0 and the range of alpha is from 0 to 90 degrees. And find the value of theta if S is 1450. Here is the solution. Number 1, the area of triangle ABD is half AD times BD sine theta. So we can put in the value. We know that AD is 60, BD is 50. So it becomes half 60 times 50 sine theta, and it gives us 1500 sine theta. Okay, next I want to find the area of triangle BCD, which is half times BD times CD times sine 90 degrees minus theta. Okay, BD is 50, CD is 40, and the area of triangle BCD equals 1000 cosine theta. Therefore, the S equals the area of triangle ABD plus the area of triangle BCD, which is 1500 sine theta plus 1000 cosine theta. So we have shown the equation. Number 2, so what we need to do is we want to convert this area into R-formula. Okay, 1500 sine theta plus 1000 cosine theta is equal R sine theta plus alpha. We identify that the A is 1500 and the B is 1000. So the R equals square root of 1500 square plus 1000 square, which gives us 1802.78. And the alpha is inverse of tangent B over A, which is tangent inverse of 1000 over 1500, and the value is 33.69 degrees. So now we can rewrite the expression 1500 sine theta plus 1000 cosine theta equals 1802.78 sine bracket theta plus 33.69 degrees. Okay, here is the solution for 3, right? Given that S is 1450, okay, now the equation becomes 1802.78 sine bracket theta plus 33.69 degrees equals 1450. Okay, so sine theta plus 33.69 degrees equals 0.8043. Now, sine is positive, we find the best angle first, which is 53.5 degrees. Okay, sine positive, which is the first and the second quadrants. So the theta plus 33.69 degrees equals 53.5 degrees, and 180 degrees minus 53.5 degrees. Okay, simplify, and theta equals 19.8 degrees and 92.8 degrees. Okay, and we know that the theta is less than 90 degrees. Therefore, theta should be equals 19.8 degrees. Okay, here is an example that you can try yourself. Given this diagram, so the diagram shows a metal plate in the shape of a trapezium in which angles NKL and KLM are right angles. The lengths of LM and MN are 5 cm and 12 cm respectively. The acute angle KNM is theta radians. So number 1, show that the perimeter is given by P equals 22 plus 12 cosine theta plus 12 sine theta. Number 2, find the value of R when 12 cosine theta plus 12 sine theta is expressed as the R formula, which is R cosine theta minus alpha, where R and alpha are constants and hence state the maximum perimeter of the plate. 3, show that the area of the plate A cm square is given by A equals 60 sine theta plus 36 sine 2 theta. Okay, you can pause the video and try to solve it yourself. Okay, here's the solution for the first one. Okay, we can draw a dotted line here and label this point as O. So now we can say that sine theta equals OM over MN. And we know KL equals OM, so hence it is equals 12 sine theta. Next, cosine theta equals ON over MN. ON will be equals 12 cosine theta. So the perimeter will be P equals KL plus LM plus MN plus KN. So which equals 12 sine theta plus 5 plus 12 cosine theta plus 5. And we simplify it, it becomes P equals 22 plus 12 cosine theta plus 12 sine theta, which is shown the correct answer. Solution for number 2. We identify that the A is 12, the B is 12. And we can get the R value, which is square root of 12 square plus 12 square. And we get R is square root of 288. And next, we find the alpha is inverse of tangent 12 over 12, which alpha equals pi over 4. Okay, now the perimeter, we can rewrite it to becomes 22 plus square root of 288 cosine theta minus pi over 4. Okay, and we want to get the P maximum, which is 22 plus the amplitude of the cosine function, which is square root of 288, and the answer is 39.9 meters. Okay, answer is 3 simple figures. Okay, now here's the solution number 3. Okay, the area, this is a trapezium, right? The area will be half times LM plus KN times KL. So which gives us half times 5 plus 12 cosine theta plus 5 times 12 sine theta. Then we simplify, it is 6 sine theta times 10 plus 12 cosine theta. So expand, we get 60 sine theta plus 72 sine theta cosine theta. Okay, we can rewrite it becomes 60 sine theta plus 36 times 2 sine theta cosine theta, because we can convert the 2 sine theta cosine theta becomes sine 2 theta. Therefore, it is equal 60 sine theta plus 36 sine 2 theta, and it is shown. Alright, that's all for this video. Thanks for watching. Do you have any questions or thoughts to share? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, I will see you in the next video. Have a great day ahead.